Okay, one thing I did forget to mention was in the thing was these people who tie balloons together and do all these things with balloons. Now, why? And a lead balloon will work. You can look an 11 kilogram lead balloon. So, what would be the dimensions? That's a fun little that would be a question I would ask my physics 210 students. In fact, I think I will. I think that'll be a test question. Is what would the volume of a 11 kilogram lead balloon have to be? Okay, so for it to float, in other words, its density would have to be less than air. So what would be the diameter of such a balloon? That's just a fun freaking problem. I want to think about that for right now. So this is what I do sometimes in regular class. I kind of go off on a thing. So if we think about it, we want let's just say we want this balloon to float. So we want the density rho. This is a sidetrack. I'm going to put it on here so in case you get these notes, ignore if you want. Side. So rho right here, rho, we want it to equal 900 kilograms per meters cubed. So what would have to be the diameter of this balloon? Or radius, and we'll multiply that by 2 and we'll figure it out. If it's 11 kilograms and we want it to be made out of lead, okay, that, in fact, I think this is going to start to become a trickier problem because the density of lead is, well, let's look it up. Oh, so this gets much more tricky than I thought. I'm sorry I'm taking you on this wild goose chase, but anyway, but it's fun, damn it. All right, this is science. This is what you do. Density of lead. What is the density of lead? Because all of a sudden, in kilograms per meters cubed, the density of lead, 8,500. Let's call it 8,500. Or a metal alloy. Bronze, lead. Okay, let's say 8,500. 11. Oh, there it is. It's 11,340. See, they were putting all that brass and crap with it, or copper with it to make brass. It's 11,340. So your lead balloon. So I've got to figure out if I have 11 kilograms of it and its density, mass is equal to density times volume. Okay. Mass is equal to its density times its volume. You have to be really small for it to float, but its density has to equal 900. So I have to create something that equals 900. That's something I really got to think about. Think more about. Because I am going to make this a question on my final for physics because it is such a cool question. All right, so I was sitting there mulling that over, people, and I didn't show you what I was going, But I'm going to write down, so the density of lead, we know the density of lead is equal to 11,300 kilograms. So look at that. It's 11 times more dense than water, and it's like 10,000 times more dense than air. So I'm going to have to fill it with air, with hot air, with helium. See if I can make a helium balloon, and I have to figure out what the density is. That is such a fun problem. I don't even know where to start in my excitement. You all just wound up. You all just got off the bus at Geek Central. All right, sorry. Let's. What now? What do we do now? Oh yeah, what do we do now, Lieutenant? Here we go. We're gonna go look at this exam real quick. All right, I haven't loaded it yet. Let's take a peek at it. Look at all these. I got all these YouTubes loading up here. We better get on this. Has multiple attempts. You can save and resume later. You can get through it once. All right. Here you go. These are all general, you know, the multiple choice, I'm going to let you all figure it out. You know, this was in the William Trubridge thing. This is the Can Crusher things. Okay. I want you to find a cube with a length of 6 centimeters on each side, length times width times height. But I want you to do it in cubic meters. So question 12, what the heck would question 12 look like? Um, let's take. I can't go over 15 minutes, and I think I already have for these YouTube. So I want to stop here, and then this is well, what do we have here? What's downloading here? Processing 0 because I've got too much shit going on. Stop, loop. Excuse me. Track 13. So this will be track 14. All right, so we're gonna close off here, and I'll come back to this right away. First, I've got to show you Moose's home run.